Welcome to The Explainer. Today, we're going on a seriously fascinating journey into an 800-year-old engineering marvel. We're looking at a machine that completely flips our understanding of historical technology on its head. And honestly, it forces us to rethink everything we know about the origins of automation. I want you to start by just imagining walking into a grand medieval palace. You look around, and there are absolutely zero batteries, no electricity, no computers, literally none of the modern tech we rely on every single day to make things move. And yet right in front of you stands this massive, towering machine, operating completely automatically. Okay, let's dive right into this. The biggest question we have to ask here is, how on earth did an 800-year-old machine tell time? And to be clear, we aren't just talking about some simple sundial. We're talking about an enormous mechanical elephant that could somehow keep time perfectly and entirely on its own. To figure out this mesmerizing machine, we really need to meet the mastermind behind it. His full name was Badi al-Zaman Abu al-Iz Ismail ibn al-Razaz al-Jazari. Living from roughly 1136 to 1206, he was a brilliant court engineer in Diyarbakir, which is in present-day southeastern Turkey. And you guys, he was a man so far ahead of his time, it's actually mind-blowing. Al-Jazari's incredible legacy is defined by one staggering number: 50. Around the year 1206, he finished his now famous Book of Knowledge of Ingenious Mechanical Devices. In this absolute masterpiece, he meticulously documented exactly 50 ingenious mechanical devices, thoughtfully sorting them into 6 distinct categories so others could study and learn from his work. The sheer scope of his genius? Breathtaking. He wasn't just tinkering with a single idea. He was out there designing water clocks, candle clocks, water-raising machines, automatic fountains, and these super intricate mechanical vessels. It really just highlights this deep, driving obsession he had to understand exactly how machines could move and perform useful tasks totally automatically. And that brings us directly to his absolute crowning achievement, the spectacular elephant clock. I mean, picture this visual. You've got a massive, incredibly decorative elephant. Right on its back sits a small structure, kind of like a tower or a canopy. There's a figure sitting right above the elephant, surrounded by other complex mechanical figures, and even a bird perched right on top. It was quite literally designed to be an absolute spectacle. Now, what's really interesting about this is the stark contrast it presents. When we think of modern clocks today, we instantly think of electronic circuits or tiny precision mechanical oscillators. But Al-Jazari's system? He used the most basic elements from the physical world: water, moving floats, hanging weights, ropes, and some seriously clever mechanical linkages to achieve the exact same automated result. So let's break down the secret hidden right inside the belly of that elephant, just so we can really grasp the engineering here. Here's how this brilliant physics application actually went down. Step 1. Water gradually enters a hidden container at a highly controlled rate. Step 2. As that water level changes, it causes a float to move. Step 3. That precise movement connects directly to other mechanical components. And finally, Step 4. This triggers a flawless sequence of automated actions. Honestly, this machine was so incredible that it didn't just display time, it performed time. That precise sequence of actions we were just talking about, it actually caused the mechanical figures to suddenly spring into motion at specific intervals. A bird would literally produce a sound and a figure would drop a ball. Al-Jazari took simple timekeeping and turned it into a fully automated theatrical show. But a huge takeaway here is that this wasn't just some fun parlor trick. The aesthetics had deep, intentional meaning behind them. The choice of an elephant wasn't just random. It specifically represented India and was a foundational piece of a much larger, highly symbolic design that was meant to convey a real message. His design brilliantly united diverse civilizations into one single machine. You've got the elephant representing India, sitting alongside imagery associated with different regions and cultures from all across the known world of the time. It was this really powerful statement, showing how global knowledge could be beautifully brought together into one spectacular creation. Okay, let's shift our focus from the beautiful artwork back to the complex internal mechanics, what we can essentially think of as a medieval machine with a hidden brain. Behind all that stunning external decoration, you had weights helping to drive the entire system, and floats that were precisely responding to the changing water levels to control every single movement happening on the outside. So, the absolutely crucial point we need to understand here is that automation can come from carefully controlling energy and motion. Al-Jazari proved literally centuries ago that machines for sure do not need electricity to be automated. If you can carefully arrange mechanisms to transform a continuous movement into specific actions, well, you've achieved automation. And we actually know all of this today because of the incredible historical value of his book. He didn't just jot down some vague ideas. No, he provided detailed structural descriptions and highly precise mechanical illustrations. Because this medieval Islamic engineering was so well preserved, we can study his exact drawings today rather than just relying on, rumors of ancient machines. This perfectly illustrates the true breadth of medieval experimentation. Whether we're talking about hydraulics, mechanical control, early automation, or these complex moving systems, all of his broader experiments were driving toward one ultimate, highly ambitious goal: figuring out exactly how to take simple natural forces and turn them into perfectly controlled motion. Now, this brings us to a really fascinating question, and it's one that actually comes up a lot in modern discussions. Was Al-Jazari actually building early robots? It's a super common claim nowadays that he's a pioneer of robotics, so we really need to set up an important distinction here so you can fully grasp the nature of his genius. To answer that, we first have to define what automata actually are. Simply put, they are mechanical devices capable of performing actions automatically, based entirely on their physical mechanisms. The word robot actually belongs to our modern age, and it generally implies a programmable machine. Al-Jazari wasn't building that. Instead, he was building automata. He was successfully exploring the core concept of a machine acting on its own, without needing constant human control. Which is exactly why we can truly call his work the dawn of automation. More than 8 centuries have passed since his book was written. Today, obviously, our lives are filled with digital clocks, smartphones, computers, and AI. Our technology looks entirely different on the outside, but here's why this matters. It still heavily relies on the very same core mechanical concepts that Al-Jazari was mastering way back then. Let's move on and see how this maps perfectly onto modern engineering. Because the workflow, it's identical. Control the energy, transfer the motion, create a sequence, make a machine perform a task automatically. That is the fundamental idea behind almost all modern engineering, and it is the exact same workflow Al-Jazari was using 800 years ago. Perhaps the most revealing insight of all, though, is translating his medieval genius straight into today's tech terminology. Think about it. In the elephant clock, water became the source of timing. The floats acted as physical sensors, and the mechanical components, they served as the controllers. It's just a stunning display of engineering imagination that seamlessly bridges the centuries. I want to leave you with this final, kind of provocative thought to ponder. If a medieval engineer in the year 1206 could perfectly automate a magnificent, incredibly complex machine using nothing more than a steady trickle of water and some brilliant mechanics, what invisible forces around us right now, today, might power the automata of tomorrow? Thanks for joining me on this explainer, and hey, keep questioning the mechanics of the world around you.